Welcome to Visual Design Week 1. And today I will first start out with talking a little bit about the structure of these meetings. The goal of this course is, on the one hand, to sort of teach you a little bit of typographical rules, layout in general, composition, color, essentially anything that it takes to make an interface beautiful. And it is more about the craftsmanship than the actual art. So I will not expect you to come up with art pieces. That will not be necessary. But I would like you to learn the basic rules about how things are done. And once you know all these rules, then you can also later on decide to break some rules. But unless you know the rules, it's pretty pointless. And this is a very difficult thing to teach because it really escapes formalism. So I cannot give you some formulas, mathematical formulas, though. If you just follow these, then it will look beautiful and everything very nice. What you need to do is to develop a sensitivity. That's, I guess, what it's all about. Developing a sensitivity to beauty. So that when you look at something, that you can judge, well, this looks good, and this does not look so good. Being able See, most of the time, the problem is that people don't even see the difference between a good design and a not so good design. It's like they look at them, it's like, well, both are fine, whatever. So it is actually being able to have things enter your consciousness, that you actually see the difference about why something works and why something doesn't work. That is this kind of sensitivity. Being able to see, being able to perceive, and once it actually you see it, you can then make decisions about, okay, I'd rather do it this way than that way, right? And this sensitivity, again, is something of a feeling, really. It is very much a feeling, and it's difficult to teach. And also, the only way to actually learn how to do it is to do it. There's no other way. I don't know of any other way. So the only way you develop the sensitivity is to do things, to look at them, to reflect on them, and then do it over and over and over and over again. So in that sense, if you are expecting sort of like, textbook style kind of, this is how it's done, it doesn't work that way. However, I tried my best to come up with all the possible rules of thumb that there are. So to give you some guidelines on which way to go. But as it is with rules of thumbs, they work often, but not always, and there's always a way around it, and you can always do it differently, and it still looks good. So these kind of rules of thumbs are not absolute. They're really just guidelines. The way these meetings are going to work is that usually we would start out with reviewing the tasks that are set out for the last week, and we just have a look at it and talk about it. And that's this kind of this reflective part, where you bring your work forward, and we all look at each other's work, and we talk about it, and see what we like and what we don't like about it, and so forth. This is the reflective part about it. And this very much happens in the style of a conversation. So it's not just me going around, talking, but, I want you to express your opinion, because you are the ones who have to start developing the sensitivity. Then we will actually have, a bit of a lecture, and also there I prefer a bit of a dialogue. And then I'll set up a new task. The tasks are being submitted through the Learn environment. And the way I want you to do it is, upload it. Most of the time it's a PDF file. And I want you to do last name _ task number, because that's, it helps me to identify, whose file belongs to whom. That makes it much easier for me. So please do that. Clear? Questions? Not yet? So, and now the conversation starts, in the sense that I will just start asking questions. So, usually when you are, let's say, working with visual design on a computer, there are two types of graphics, or two types of representation inside of a computer that you can use to essentially represent graphical elements on the screen. Can you think about these two different ways? So you learned something. Wonderful.
two ways of representing.
Yeah, so if you have a graphical object on your screen, usually there are two ways of representing them.
Either bitmaps or vectors.
Exactly. And what's the difference?
Bitmaps are built pixels. Like saying this pixel. And vector is more organized.
Does that mean vectors can be infinitely scaled?
Yes.
Nice. Having a lot of stuff, and it makes sense.
So that's actually, a very good description. So what you would have in a vector graphics is that it would actually literally, if you open a PDF file, it's just a text file. And in the text file, you would actually see, a coding which would say there's a circle at this position with this radius. So everything is expressed through mathematical formulas. With the bitmaps, it's literally just a grid of information.
Obviously, there'd be some compression.
Compressions are possible, and we get to that. Now, what's the advantage of vector graphics?
Infinitely scaled.
Yes, very nice. Scalability.
The bitmap, I presume, when you scale it, then it has to infer the new colors in between, or just scale it so this pixel's now 4 pixels.
Quality.
I can't remember the word when you take the colors and pick the average in the middle.
Yeah. So that's essentially it. Scalability is Is there any good points about bitmaps?
They don't take up that much space. They are this.
Probably slightly easier to edit.
Not necessarily, huh?
Go into the base code and start changing stuff.
Right. Well,
Because when people have vectors, they often say it takes like 12 hours to build. But when people do other graphics, it seems to be quite fast.
yeah. But that's on the computer side.
Yeah.
Yeah, but so usually with the graphics, if any of you is able to max out your computer by using Photoshop, congratulations. Usually the bottleneck is the human, not the computer, in this type of tasks. So that's not so often the problem. But why would you use bitmap anyway?
It's what paint saves it.
So what kind of graphical objects usually come in bitmaps?
Screenshots.
Yes. So it's an interesting thing. So your screen is in?
Bitmap.
Yes. So your screen is in bitmaps.
Scale it.
So whenever you have vectors, eventually you'd have to transform it to bitmaps because your screen is a bitmap. But there's one other really huge area in which bitmaps are being used.
Computer vision.
Yeah, exactly. So what does computer vision do?
Takes the pixels and tries to work out what's being seen.
Can actually look up a pixel.
Right, but there's a certain input device there. And what is that?
Camera.
A camera. Okay. So do you have a camera? What kind of camera do you have?
Camera.
What kind of camera is that?
Yeah. Yeah. What kind of camera it is? It takes, the images you take, they could become digitalized. So, do the bitmaps.
Right. So is it a photo camera?
Yeah.
Okay,
A photo camera. So for what big area then is bitmaps used?
Photography.
Photography, of course. If you take photos, you get bitmap data. It's just the way it is, right? In photography, it's a very big section of design in general, right? So very often you end up with bitmaps anyway. Now, in terms of size, usually it's the other way around. See, if you have to represent a circle on an A0 type of poster, right? If you do it with vectors, how much space will that file actually take you? So there's no difference. But if you have an A0 in bitmap, huge, exactly. So in that sense,
what resolution is it going to be though?
we're going to come to that. So that means usually bitmaps take much more space, simply because you actually have to, represent every pixel, right? With the vectors, it's not necessary. So in terms of size, usually vectors are superior, unless your background is a photographic background, then it doesn't matter anymore. Now, if you wanted to convert a vector into a bitmap, what would you have to do?
Map the vector onto a grid and take the largest color at that point. Each thing of the grid.
That is correct. So this is called rasterizing, right? You put a grid over it, and then you just look which of these grids has, a majority of black, and that will become black. Now, you asked an interesting question before about resolution. So in this left column, what represents resolution? The size of the grid. So the finer the grid, the higher the resolution. And you can also do the game the other way around, right? You can also take actually a bitmap and turn it into a vector.
How well would that scale though? Is the bitmap turned into a vector?
Well, once it's a vector, scalable indefinitely.
Yeah.
The only question again is, how detailed do you want it to be traced? So ultimately, you can trace actually every pixel, and then you get a rectangular for every pixel, right? Possible, but pretty useless. So what you usually do is that you find areas of common color, and then you sort of like merge it together. That's why these graphics very often,
Interpolating, is it?
well, you just summarize it in a way, and that's why you get this kind of picture over there where you actually have larger areas of the same color being merged into one with one color. So it's a certain type of visual effect that sometimes is appealing. So usually it's being used for that purpose. But sometimes also it's like when you, for example, have a logo and the original file got lost. Well, then you scan it in, you get bitmap. And then you trace it to get into vectors. And then you start manipulating the vector to clean it up, essentially. So now comes the nasty question. What is the size of one pixel?
Talking computer terms? In computer storage? About 4 bytes, depending. Got red, blue, green components, alpha, positioning, so probably getting up to around 8 bytes. That's only 256 color per values per pixel, though.
Yeah, that's very good points. But in terms of output size, visual size, how big is the pixel?
Depends on the screen. My computer screen has pixels that are 0.25 of a millimeter to the side. Just depends on the resolution of the screen.
Very good point. Now, resolution then. What does resolution actually mean then?
The amount of
Just a question. One step back. So when you say, it depends, the size of a pixel depends on the output device. That means a pixel in itself has
no size.
no size at all. It is just a piece of information, right? So it all depends on the output device. And that cannot only be the screen, it can also be a projector, it can also be a piece of paper, it can be all sorts of things, right? So pixels itself have no size, other than the file size in memory of the computer. It's a different story, okay? And then resolution is?
Given the size to the pixel on the screen.
Right. And what would be a good unit to measure that?
Height by width.
Yeah, exactly. So very often this is being a typical way of measuring is DPI, dots per inch.
Is there a metric unit?
Inch is not metric. So in that sense,
Is there a metric unit?
of course, you can just say dots per centimeter or dots per, So you can do that. It doesn't really matter. But the important thing is that you have essentially the pixel or the dot on top and, a length unit in the bottom, right? So if somebody would ask you, what is the resolution of your screen? What would be the appropriate answer?
I'd probably say it's 1680 by 1050.
And is that a resolution?
Yes.
So it's not the right answer.
I have to work this out now. Let's see, it's 40 to the sun. 1600 pixels per square. I can't be.
Something like that.
Oh, per
So
square
the
centimeter.
point is, it's a common misconception that if you ask people about the resolution of the screen, what they tell you is the number of pixels. But it's not the resolution, because that depends on... Yeah. So in that sense, it's a problem. So when we talk about resolution, we mean actual resolution, not the number of pixels, right? Now, the interesting thing now is DPI, D, dots. Interesting. So what is a dot?
Presumably you're referring to the pixels on the screen.
You actually use the dots when you print. Like an image.
Okay. So this gets interesting, right? So there's pixels, which we have on the screen, and there's dots.
A single unit of color.
So what is a dot?
A single unit of color, I guess, on the screen, chosen to be at that point by.
That is a pixel.
No, it's the pixel in the physical world.
Ah, bit of a mystery. So who of you has ever done any kind of graphics for the web? So in what resolution do you save your JPEG? Why 72?
It's standard for what we use.
Why?
Originally, that's something to do with first printing out paper.
Not exactly, no. Well, roughly, not exactly. So another mystery. We all do it with 72, but nobody knows why.
It's tradition, you don't change tradition.
Well, yeah, but it usually comes out of something.
Right?
Okay. So let's try to take it from another angle. So we've got two mysteries right now, the 72, and we don't know what a dot is. Right? Now, let's throw in a third mystery. If you were using Microsoft Word and you decide to put on your typeface a size, let's say 10 points, and you print it, how tall would it be?
It used to be based off height of the printer. Presumably, if it was 10.1032 of an inch or something like that.
Or 10 dots. Actually, bring the dots.
Well, which one? So, are you telling me that you're using Microsoft Word every day, you choose 10, 11, and 12 points, and you don't even know how tall it is? Interesting, huh?
I don't really know what it wants, but
So you could actually use centimeters or millimeters, and that will be clear. So you're using a magical unit that you don't know what it is.
like shoe size. Shoe some sizes and should barley corns.
Right. So what happens is just to let you know, a point in terms of 10 points of font size. No, it is. See, this thing comes actually from printing, and printing is a very old activity, so to speak, hundreds of years old. And The point is a unit of measure that they used. It's just a traditional one, right? And it's 0.35 millimeters. And the interesting thing is that there are 72 points in 1 inch.
That was close.
So 72 points to an inch, that's 0.35 millimeters. So does that ring a bell with 72 dpi? So where's the connection? Mm-hmm. And if you save your files with a resolution of 72 pixels per inch,
It'd be an inch file. It'd be an inch when you print it.
so that means yes, under one assumption, that is the important one.
The printer also prints.
Not necessarily your printer, because we're talking about pixels.
The screen is 72 inches.
Exactly. If your screen has a resolution of 72 pixels per inch, then 1 pixel equals
1 inch. Oh, sorry, well, that of an inch.
172.
so 1 point. 1 pixel equals 1 point. Right? Now, there was a time when the first, essentially, graphical user interfaces came about. And it was mainly Apple at that time who introduced it. And they had to make a decision for the computer screens. What resolution should it have? And they decided that a screen should have the resolution of 72 pixels per inch. So that when you decide, that essentially 1 pixel on the screen would be 1 point, 0.35 millimeter. So what you see on the screen, if you have a rectangular, which is 10 by 10 pixels, it will be the same when you print it as 10 points by 10 points for the matter of a typography. So when you see an Helvetica, a large M, capital M, and it's 10 points, it will be 10 pixels on the screen. So that what you see on the screen is exactly what you see in print. That was the original design.
I'm guessing it's changed a fair bit nowadays.
These days, there are no more monitors left which have 72 dpi. That means whatever you see on the screen is actually smaller than what you see in print.
I'm fairly sure my screen's about 100 per inch.
100 pixels per inch, yeah.
So now, so I presume Word presumably gets around that by setting the size to 100%.
No, what you do is, by now, so you've got zoom and all kind of other things. So, but the important thing is, at its original conception, this was a really good idea, because what you see on the screen is what you print, and that's what you want. These days, this is not the same anymore. So the only way to see if your typeface is the right size is to print it, look at it, and see, well, it looks about right. It's a pity. So, since we are now talking about units, our laser printer over there, how many colors does it have?
Well, 3 color. Laser printer. That's black.
Yes. So, laser printers have 1 colors. And let's say if you would have, we also have a color laser printer, how much does the color laser have?
Well, that's 6. 3 colors and 1 black.
Yeah. Which ones are, which are they called?
Yeah.
Yeah, for black. So it's called SMIC.
I've seen some with 6 for colours.
Yes, inkjet printer these days sometimes have 6 or sometimes even 8 inks, and we get to the reason about why that is. Now, to make things even more fun, we've discovered now DPI. So dot actually means point.
A point?
Does not always mean pixel. That's the tricky part here. So the unit point dot is actually quite confusing for many. But to make things more tricky, in the printing world, you also have something called LPI, lines per inch. And that has something to do about the printing method it's being used. So as a rule of thumb, and I've not yet been able to find any really good explanation of what the connection between LPI and DPI is. And I've looked. If you find it, let me know. I'm really curious. In any case, as a rule of thumb, if you have if you have a good printer.
Could it be to do because the old printers used to go back and forth? And
No.
so that'd be like 150 swipes per inch?
No, more complicated because lines per inch, as far as I could tell, depends on, in the offset printing way, they have holes. And the question is how many holes you have in the line. So it's a bit more complicated, but the connection is, I asked several printers and it was very difficult to find good answers. But anyway, as a rule of thumb, if you have a photograph in there, if you shoot for 300 dpi, for vectors it doesn't matter, right? Scale, so it doesn't matter, right? So, but for photographs, it's no use going higher than 300 dpi. You will not get any better looking prints just because you got your photograph in 600 dpi. Doesn't make a difference.
Presumably it would print every second line then? Different.
Well, it just doesn't help whatsoever. No. So what you see also here on the right is the grid usage for the different type of printing. So actually for newspapers, it has an LPI of 91, and that's less than actually newspaper 85 dpi. So newspaper usually goes with 85 dpi. That's all it's got. Well, that's okay. It's good enough. You don't need much more. And only if you go for really high glossy prints, even then 300 is sufficient. Well, you don't need more than that. Now, let's do some more sizes. Usually I sneak around and take a piece of paper. So, what size is this? What does it mean, A4?
It's 200
All 33.
297 by 210 millimeters.
Okay.
I know there's an actual unit, but I can't remember what it is.
Oh, that's fine. That's fine. So, that's all very nice and good. And you said half an A3. So what happens if you put two of them together? Okay. So if I fold it, and if I fold it, right. Now, that's very easy, right? Now, the interesting question is, of course, this is the nice thing about it, actually, it keeps its proportion. The proportion is always the same, right? Now, the interesting question is now, do you know what the proportion is?
Roughly 7/10.
Probably looked it up sometime, but it's never really used.
Right?
Is it the
Golden ratio? I think so, yes. Now, the interesting thing now is the following, or the really interesting question. This just describes the ratio. But still, at some point, you have to put this into absolute terms. So at some point, you have to decide A0 is 210 by 297 millimeters. Why that absolute measurement?
I would say it probably has to do something with printing as well.
Yes, it does, as usual. So just this first question, what does DIN actually stand for? What does DIN actually stand for? Mm-hmm. Deutsche Industrienorm. It's the Germans who came up with this. So still, why the absolute measurement of 210 by 297?
It's something to do with the amount of letters you could get on the page when everything was monospaced.
Yeah, what a good guess. Okay, you probably don't know, so I have to guide you towards this. As you discovered already, it's like a lot of things have to do with printing, right? The printers have a problem. The problem is that they print millions of copies, right? So when they get paper into the printer,
their reams cut up because they get big reams of paper. It's just
roughly, it's about mass production. So what you get is like you get truckloads of paper, right? And let's say you ordered 20 million sheets of A4. How on earth are you going to know that it is the exact amount? You cannot go counting the pieces of paper. You go crazy. So what's the answer? Weigh it. Exactly. Now, the idea is, of course, that if you know how heavy one piece is, then by weighing it, you know how many pieces of paper are on there, right? To make things nice and easy for themselves, they decided that A0, what's the size of A0?
Size?
A0.
16 times the size of A4.
Nice thing is that A0 is exactly 1 square meter. That means if your paper is delivered, large size, let's say in A0, and you know the density of the paper, what can you do?
Calculate how many sheets are there?
Exactly.
What's the thickness of the sheets?
Well, thickness doesn't matter because you just weight. But thickness depends, of course, on the density of the paper again.
Oh, yeah.
So if you have a normal office paper, how heavy is it? It's density.
But density depends on the thickness to get the weight of the sheets. So if you get a really thick sheet, then
Okay, so density, it's not three-dimensional. So how is density, how is the weight of the paper actually usually measured?
9 grams per square meter.
Exactly. So
terrible.
what's the normal office paper?
About 80 grams.
80 grams. So 80 grams per square meter is usually office paper quality. So if you know that, you can then actually, when you have a scale, you put it on there and you know 80 grams per square meter. And let's say you have A0 sheets and you know A0 is 1 square meter, you can very easily determine the number of sheets that are on there. Right? Which brings us to another interesting question. So you know DIN A4. Do you know DIN B4?
An imperial version of paper.
No, Germans wouldn't go for the imperial way. That's across the channel.
I think we're slowly turning metric.
Yeah.
I've noticed if it's a long journey, it's done in miles. If it's a short journey, it's done in kilometers.
Well, the British recently converted to the metric system a couple of years ago, so there is indeed some progress. But in any case, so what's DIN B?
Is it 1.5 square meters?
I bet each and every one of you had in their hands a DIN B4.
How's it books?
It's not books. It's envelopes. A fits into B, B fits into C. How utterly useful. So if you want to mail an A6 postcard, what kind of envelope would you get?
B6.
Exactly. Now, the imperials, in terms of the US, are not as advanced, so they've got a very well, less sophisticated system. They've got 3 sizes, letter, legal, and tabloid, with the inches associated to it. Letter is almost the same as A4. Again, this the proportion they use doesn't scale up, so letter and legal has got different proportions. So if you want to make sure that if you have a document which you want to send out internationally, just be aware that letter is not quite as tall as A4. So don't put anything at the very bottom, at the very top. So if you email it out to other people and you send it out to Americans who've got letter printing, it will just be cut off. Just be aware of that.
Set word to letter count.
Sorry?
You can set word to automatically get around that count.
Yes, but then you go the other way around. If somebody opens this with, in the European way, then you get the same problem again. So essentially, you want to stay within the overlap of the two. Now,
Is that why with such large margins at the top and bottom? It tends to be about an inch or so.
No, I don't think that's a particular reason. I think it's style. So we've got sizes of paper. Now let's talk about sizes of screens. So I'll just throw it on. These are the different sizes we have for screens. And there are several different proportions, 4x3, 5x4, 16x10, 16x9. So this is roughly what we have these days. And you see it's a great variety. And that also means for your designs, it makes it kind of complicated, because your designs for screens has to be flexible enough so that it actually is visible on most of these screens, or it fits in somehow.
So I really don't get the decision like the MacBook immense.
Retina display, yeah, that's going to be an interesting one. And of course, particularly if you do screen design, like a web page design or whatever, the problem is you never know what your end user will have, right? So there's a nice tool from Google, which is called in Google Apps Browser Size. And what they do is that they type a URL, and it shows you what is it that people actually see when they look at a certain web page, and also the proportion of people who actually have that. So you see now 90% of the people will see that, 80% will see that, and so you've got the safe regions essentially. And on the left, you see, the different types of standards that we have, and they vary considerably. So particularly old video standards are very nasty, very difficult to get your head around those. If you ever want to take a shortcut in terms of calculating your screen resolution, this is a nice website. It's linked from the Learn environment, where you just type in your resolution, and it gives you the all the DPIs and everything that you need for it. Right. Now, coming slightly back to sizes and formats, we did already the weights. So here's the different type of papers that you have: cardboard, passport, and so forth. The other important thing for you is, of course, file formats. We talked about compression. Now, let's say if you have a photograph and it's a JPEG, and you open it and you save it, and then you open it again, and you save it again. You open it again, you save it again. What happens?
One would hope nothing, because you're dealing with digital information. You're probably going to... I mean, you'd be losing stuff through transmission errors, but one would hope not. But considering it says lossy up there, I'm guessing you're losing information every time you save it.
Yes, you do. So what does JPEG actually do?
Compresses, I guess.
And how does it do it?
Probably some algorithm to work out where groups, colours are. And
What's the basic assumption there?
I guess that it uncompresses the same every time.
No.
Or it compresses the same.
No. So what essentially JPEG does, it removes information that humans tend not to perceive. Same as MPEG-3, roughly speaking. Not a different algorithm, but the idea behind it is the same. So you leave out information that usually you would not perceive. But it does it every time you save. It means when you open it, edit it, save it in JPEG, you lose information. You open it again, and so forth. That means if you do this 10 times,
It could be a fun program to write.
It will look horrible. So what does it mean for your daily work?
You want one base copy that you edit every time rather than
Oh, it's...
don't use it.
Don't use it. You only use it once. And when do you use compression? The very end. Any kind of editing that you do, it's not a good idea to use any kind of file format that has lossy compression. Another illusion that some people have is like, well, if it's JPEG, it's only 1 megabyte, and my memory doesn't, my computer doesn't have that much RAM.
Maybe in the 80s.
No, you still meet these people. So if it is compressed, it only means the file size on the hard disk is smaller. It makes no difference when it's open in your Photoshop. It doesn't make a difference. So you don't save anything in terms of processing speed, in terms of RAM, when you use JPEG. Right?
Have you seen the blue marble pictures of NASA that NASA releases? They will literally use up all your RAM.
Yeah, I mean, there are, you can do very, very large pictures.
It's the ones they've taken from the space station of Earth, 2,500 by 25,000 by 25,000.
But JPEG wouldn't help you. That's the story here. So essentially what you have is, if you want to play safe, and if you use Photoshop, just use PSD Photoshop file, you'll be fine. Otherwise, TIFF is a very good safe way of transporting bitmaps without compression. If you want to go with compression, particularly for the web, and that's the only time you need compression, if you put things with the internet, it's JPEG, GIF, and PNG can have compression. If you go for vectors, interesting thing, PDF. What is PDF?
It's Adobe's Max for documents and things.
Yes. Why PDF?
It saves as a vector.
And you can't edit it. It's official. Can be changed.
That's a practical use of it. But why did they came up with PDF?
Saves the documents as a vector.
Yes, but you could have used you could have used PostScript.
It compresses it without, the bent uncompresses without losing information.
You could have used any other vector format. Okay.
Everyone uses it.
Let's say we use Illustrator, right? And if you make a design in Adobe Illustrator, you save it in Illustrator, and you send it to Timo, and he opens it, what happens?
Oh, they say nothing. So that depends on how you save it, right?
Right.
Save the document for him to open.
So have you ever seen a situation where you open a Word document, it all looked messed up? And why is that? Yes, but there's also a reason behind it. That's also happening. There's one big hiccup usually. No? Let's say you've done a really nice design and you've used a really spacey typeface.
Okay.
And you send it to him. What happens?
He doesn't have Adobe Illustrator.
Well, let's assume he has Illustrator. But let's assume he doesn't have your spacey typeface installed. What happens then?
Get Windings.
Yeah.
I don't have that in the same typeface. He's in trigger. Hard not to put something else in place.
Yes. So it will get messed up. And that's the reason why also Word messes up. If you don't have the font installed on your computer, you can't display it correctly, hence it screws up. What happens if you would save it now in PDF? What happens?
complexity becomes.
Adobe Illustrator is also vector. Same thing.
Yeah,
Not
but
vector,
there
non-vector. That's not the
it
issue.
says the font has a font.
Well, what does PDF really do? How does Adobe PDF achieve that when you have your file with a spacey typeface in there, you send it to him and he opens it and it still looks all right? How did Adobe PDF achieve this?
It saves it as an image.
No. No. Well, that's your answer for everything. It actually takes the font and embeds it into the document itself. That means it's not just your design, but also the typeface that's being sent with it. So when you look at it, you do actually have the typeface. Now, but that actually was already implemented in PostScript. So what's PostScript?
Something that wasn't as well marketed.
So who created PostScript? It was indeed Adobe. Adobe had its fingers in it. So if Adobe had already PostScript, which does everything as well, why would it still go on and do PDF? So much puzzled faces. Yeah. So what happened is, now let's go back, and it's a bit of a history lesson. First there was PostScript. Why? And why was there PostScript? That's the first question to ask. And for that you have to go one step back. The first printers that came on the market actually had the fonts installed inside of the printer. So you would tell the printer, use Helvetica, and these are the letters. And then the printer knew it was Helvetica and knew how to print it. It's all very nice and good, but you get the same problem in terms of if you have multiple fonts, the printer will not have them all. So you need something that is independent of the actual printer. Then came PostScript. And PostScript, again, is nothing else than a page description language. That means it describes in text what kind of elements there are on the page. And you can actually program PostScript with a text editor if you wanted to. Right? And that worked fine, because then the only thing that the printer has to understand is PostScript. So if you send a document to the printer, and it's in the PostScript format, it will be able to digest it, no matter what's inside. That's why even today, printers have, let's say, PostScript level 3 compatible and so forth. All very nice and good, wonderful world. But then something happened, which was called the internet. And then suddenly, you actually wanted to send things across the internet, and everything became multimedia, right? And then suddenly, it was just not only anymore about printing, it was also about other things. Like, for example, doing forms that you can fill in, to embed movies, sounds, interactivity, hyperlinks, you can click on things, things happen. So all this kind of additional functionality came along, and then that became PDF. However, there's a one-to-one matching between PostScript and PDF, because PDF for printing uses PostScript. It's sort of like an enhanced version of PostScript. So the idea is that PDF version 6 equals PostScript version 1.5. 1 plus 5 is 6. That's the basic idea. Now, software. What would you use then what is your weapon of choice? I mean, I'm going to take this away again. What's your weapon of choice for editing photos?
Photoshop.
Or if you want to do it for free?
Yeah, paint a scene.
GIMP. GIMP is a good choice. If you want to do vectors, what would you use?
Illustrator.
Or if you want to do it for free? Inkscape. If you were to make a flyer, what would you use?
Microsoft Publish.
Okay.
Well, either Illustrator or
Illustrator is fine, yeah. And if you do a brochure, what do you use?
purple one.
It's called InDesign.
Yeah.
It's very simple. If you want to do one page, Illustrator, more than one page, InDesign. It's very simple. And if you want to do something crazy interactive on the screen, what do you use? Right. That's also a possibility. So, in essence, the market has by now been pretty much dominated by Adobe. There used to be an alternative to Adobe, which was called Macromedia, and then Adobe bought Macromedia. As for Microsoft, yes, these things usually come for free with Windows.
They tend to have died off, though.
Yes, but for professional use, it's just not an option. There is still one competitor for page layout, which is Quark Express, which is still going relatively strong. It's a good alternative. Or if you're particularly in the academic world, you will use LaTeX.
To work on my PC.
Which one?
LaTeX. They won't load.
It will, and it's beauty. Particularly you as an engineer should appreciate it.
There are lots of advantages, but when I tried to install it on my PC, I tried to run it and it never ran.
Something's wrong with your PC.
Lazy and didn't. I had Word 2003, it was the last good one.
So, the task for next week is, I want you to do a logo. So, and of course the logo must be for something, right? It cannot just be for anything, right? And I want you to, there's actually two alternatives right now. One is that the classical version of doing this exercise, and one is the advanced version. So the classical version of this design is like you take a design classic, something, an object that has been proven to be of superior design. For example, from an architectural point of view, the Opera House in Sydney. Now that's a classic, right? This building is not. So you take that, and on 1A4, you write something about the design classic, about what's this product, what is it, and on the second page, you actually do the logo. Because there must be, of course, a relationship between these two. You always do a logo for something. You don't just do it out of complete fantastic reason. And then you create PDFs, upload it to Learn, and we talk about it next week.
We need to learn Photoshop in a week.
Yes, of course.
Oh, shit.
Actually, what would be the weapon of choice for this task? And why?
Normally,
Yes, why?
slice them into some posters and billboards.
Exactly. Right.
I'm an engineer, I've never touched that stuff before. It's going to be fun.
Yes, it will. Plan B is that if you have particular prior experience in logo design, something you've done a couple of times, then I would like actually to invite you to make something that might actually see the day of light, which is, can you please modernize the HITLab logo? And modernization doesn't mean turning it upside down, but a subtle improvement.
If it's good, will you use it?
Yes.
Don't think I can do that.
Okay. Questions?
Is there a computer I can use that has all these programs on it?
We'll get to that. Can you then switch off the recording? Thank you very much. And on Thursday, there's an open door where you can ask questions.